Hi there, this is Ajay. Welcome to Step by Step Data Science tutorial. So today we are in part 15. In part 14, we discussed about finding principal component in PCA. So in last video, you can see we have drawn a visualization and we have found principal component. So this was my principal component, and you can view my last video, which is mentioned in the description below. You can view how we found the principal component. I have also added the link here. You can click in this button, this icon. So today we will start with applying the principal component and how we do dimension reduction in PCA. So let's say now we know we did 3 steps for PCA. These 3 steps was mentioned in my part 14 video. You can view my part 14 video how we explained and implemented these 3 steps. So a bit of review. So now what we know is now we have a principal component. Okay. So my principal component line I got is like this. Right? So let's say this is my principal component. This is my principal component line, right? So this line is what we have received right now. So this line is my u vector, right? So this line is my u, and this is my eigen eigen eigenvector. So this was my third step, which we have implemented in last video 14, and this was my principal component eigenvector, and this was my principal component that we found, that we did on our last video. So today what we will do is, so once we have principal component, that is my u vector, now next step for calculating PCA is to project data. Now we find G which is my u transpose of X. So what is G? G is, so this is my principal component. Yeah, and what my G is, so this is my projection of each point here. So this for this one is here, for this one is here, for this one is here, for this one is here. So like, so this way I got a line, right? So this is my one line, and in this line, this line, so this is my one line. Okay, so here x1, so the x1 data, x2 for this point is here, 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 this one is here, the point is here. So this is my z vector, right? So this is my z vector, which is u, z vector is u reduced u times x. Okay, so this is what my projection data is. Projection data z is, which we will be calculating now. Let's implement this formula. Okay, so I will write a function to implement this formula. So let's say, so diff project data itself, comma x, comma u, comma k. So my m will be x dot say, and now my u reduced will be equals to you are semicolon comma semicolon key. Why I did this is because this is here. This is because so right now we have principal component u, right? So if we look at my u, it's a 2 by 2 matrix, right? So why I did here comma, I can pass my columns in a way like if I need one dimensional data, I can give one. If I need two, I can give two. So right now I need, if in case I need one dimensional data, I will pass one. I will get this value, right? So my key will be here. The key will be that parameter which I will pass. It can be how many, in what dimension we want to reduce my data. That will be my key, right? So my z will be again my z. I will declare my z dot zeros as m comma k in range of m and j in range of k z of I comma j will be will be equals to, what was my formula to calculate z? So my z will be u transpose times x reduced, so which is this x of I at the rate will do the matrix multiplication and then reduced and j return of j. So now we have projected data. Now we have implemented this line u at the rate g. So now we have implemented this line. Let's check if this is working or not. So my k will be this is my dimension. I want to convert into one dimension. This is my class which I have already declared, or I mean object of my class, and my new function is this. And here I will pass my x norm, the normalization part. So this part you can view in my part 14 tutorial, and then will be my u part, then k. Okay, so this is working fine. So my first projection line is okay, so let's print my projection of the first example. So let's say this is my chat. So what we did, we were able to find my project data, which is z is equals to u times u at the rate x. So this is my matrix multiplication. Matrix multiplication. Now what we need to do is we to transform this into our original line, right? So my x will be, so this will be again transformed into this, again this line. So here my x will be z times u reduce. So if we do this, then we will get this line back. So which is my principal component line. This is my main dimensionality reduction line is this. So let's implement that. So that is my we call it recover data, comma z comma u comma key m comma n is my z dot shape of 0 comma u dot shape of 0. My reduced is same. My x recovered is comma n in range of n x recovered of I z times I at the rate reduced transpose, and then return x. So let's check if this is working or not. X underscore like will be equals to recovered z u and k. This is my object. So let's restart and run it again. So let's take my first row. Okay. Now let's plot my x rig and check the principal component line. So this was my original x norm, and my new recovered reduced line is x rig. Let's highlight this with yellow red. So okay, here we can see the approximation so that this is my original data, and this is the principal component line which we have metric. So this was my last formula that gave us the main principal component line. So this was the formula that we implemented. Okay. So these are the 5 steps to get a dimensionality reduction from 2-dimension data to 1-dimension data. Hope you like my channel. Please subscribe and support me and like my video. Thank you so much.